Kia ora koutou. Welcome to this video on the electrical conductivity of metal. In the last video we looked at the structure and bonding of metals, and we saw that metals had the cations and the electrons, the valence electrons of metal atoms, which are delocalized, so they are free to flow throughout the substance. So if we remember back to the conductivity of ionic compounds, electrical conductivity depends on the ability of charged particles being free to move in a substance. So I'll just write that down. So electrical conductivity requires charged particles that are free to move. So in ionic compounds, we looked at the solid form of ionic compounds, which had cations and anions, which are bonded together with those ionic bonds. So the solid form of ionic compounds did not conduct electricity, whereas it did when it was in an aqueous form and when it was molten. That was because the charged particles were free to move. If we look at these, so in that case, the charged particles were ions. If we look at the word charged particles, this can mean for our purposes, just two things. So either ions, which is, in the case of ionic compounds, can be a cation or an anion. So cation or an anion. Or a charged particle can simply be an electron, because an electron has a negative charge and it is in itself a particle. So electrical conductivity requires charged particles that are free to move. So the metallic substance has got these electrons, which are charged particles, and they are free to move throughout the substance. So metals do conduct electricity. We will look at a past exam. So we have to go back to 2014 to find a past exam that directly examines this concept for metals. Normally they would talk about the electrical conductivity of ionic compounds because there's more that you can answer with a question like that. But so this is from the 2014 exam. So we've got solid magnesium and iodine were tested for 3 physical properties. The table below shows the results of the tests. So magnesium, it is ductile. We'll look into why that is in a future video. Soluble in hexane, no, and conducts electricity, yes. So we will look at how we would answer this question. So first of all, so it says use your knowledge of structure and bonding to explain the results of the test. So this is a very common way that they will ask this question. So we need to first of all state the structure and bonding of magnesium, and then we explain why magnesium conducts electricity. We'll just be looking at this property in this video. So we would use the definitions that we learned in the last video. So you can either say magnesium contains magnesium atoms in a 3D lattice held together by non-directional bonds, or you could say magnesium is made of cations non-directionally electrostatically attracted to a surrounding sea of electrons. So either or, you can say one of those. And then what you would say is that in magnesium, the valence electrons are delocalized and free to move throughout the substance. And then we just say, therefore, magnesium does conduct electricity. And that's it for this property of metals. So it's relatively straightforward. We just need to relate it back to the ability for electrons to move throughout the substance. Thanks very much for watching. Like and subscribe for more Chemistry 2.4 videos. See you next time.